Okay. Now, look, for your understanding, each and everything I make it such that you will not face any problem, right. When j j is equal to 3, n j j is equal to n 3 is equal to 5. Look at this table, when j j is equal to 3, n j j n 3 is equal to 5, because you have 5 nodes 4, 5, 6, 7, 8. So, E 3 1 will be 4, E 3 2 will be 5, E 3 3 will be 6, E 3 4 will be 7, and E 3 5 will be 8. Look here, when j j is equal to 3, n j j n is equal to n 3 is equal to 5, then your k is varying 1 2 up to n 3, that is, or k is equal to 1 2 up to 5. Therefore, E 3 1 is equal to 4, E 3 2 is equal to 5, E 3 3 is equal to 6, E 3 4 is equal to 7, E 3 5 is equal to 8. Similarly, when j j is equal to 4, when branch 4 j j is equal to 4, n 4, n j j is equal to n 4 is equal to 4, and nodes are 5, 6, 7, 8. Therefore, E 4 1 will be 5, E 4 2 will be 6, E 4 3 will be 7, and E 4 8 E 4 4 will be 8, right. Therefore, when j j is equal to 4, n j j is equal to n 4 is equal to 4. So, k is equal to 1 2 up to n 4, or k is equal to 1 to 4. That means, E 4 1 is equal to 5, E 4 2 is equal to 6, E 4 3 is equal to 7, E 4 4 is equal to 8, right. Similarly, when j j is equal to 5, n j j is equal to n 5 is equal to 3. So, when j j is equal to 5, n j j, this is n 5 is equal to 3, and you have, that is, your j j is equal to 5. So, E 5 1 is equal to 6, E 5 2 is equal to 7, E 5 3 is equal to 8. That means, your k is equal to 1 to n 5, n 5 is equal to 1 to 3 only, 3 elements, right. Therefore, E 5 1 6, E 5 2 is equal to 7, E 5 3 is equal to 8, right. Similarly, everything I have made for you such that there would not be any confusion. When j j is equal to 6, then n j j is equal to n 6 is equal to 2, that means, k is equal to 1 to n 6, the general one, or k is equal to just 2 element 1 to 2. That means, when j j is equal to 6, n 6 is equal to 2, and 2 elements 6 1 is equal to 7, E 6 1 is equal to 7, and this one actually 6 2 is equal to 8, right. And similarly, last one, when j j is equal to 7, n j j is equal to n 7 is equal to 1, when last 7, when j j is equal to 7, n 7 is equal to 1, and only one node. So, 7 1 is equal to 8, right. That means, E 7 1 is, that means, this is actually your E j j k matrix. This you have to read it into the computer, right. I am not writing again separately for you. This is actually E j j k matrix. This nodes beyond branch j j, this data you have to feed it to the computer. This you have to read, right. 2 3 4, here it is main feeder, that is why it is very simple, but when you arbitrary node also it will work. You take in between, total node is 8, but you take any number of node, you can easily identify looking at that. You have to just make those branch numbers, sending a node, receiving a node, total number of nodes beyond branch j j, and total number of nodes, right. Your number of nodes, your node count beyond branch j j, and total number of nodes, right. So, this is your E j j k matrix. This data you have to read in the computer, right. So, according to the diagram, whatever you will be plot, but here you should not make any mistake. There is no chance of mistake. If you have the diagram, you can easily make like this, the way I told you, right. So, there is no chance for any mistake, any mistake, right. Therefore, that current of branch j j can be expressed as like this. Therefore, that branch current j j, I j j, it is a generalized form. Look how we are writing, I j j, capital I j j is equal to sigma k is equal to 1 to n j j I, in bracket we are putting that matrix element E j j k. This is equation 27. Now, how it will work? How I, that means, for branch that means for branch 1, branch 2, from this expression everything will be computed, because this E j j k matrix, as long as you are reading it into the computer, you are feeding it into the computer as a data, all these things you have to put it in a data, right. So, generally the branch current, these things are very simple actually, little bit if you are look at the mathematics and little bit coding, if you know, these things are very simple actually. So, k is equal to 1 to n j j, but let me tell you one thing, in the exam purpose you will be given only calculator and hand calculation, no question of coding, but if anybody when reading this thing, data numerical will be solved, if anybody write codes and get the solution, I will appreciate you like anything, right. Very simple it is. So, therefore, your current of branch JJ, right, current of branch JJ can be expressed by this expression, this sigma IJJ capital is equal to K is equal to I capital IJJ is equal to sigma K is equal to 1 to NJJ I small I in bracket, it is EJJK matrix, this is given. Now, why we have given this? Look, that means once E matrix is read and initial values of I's are computed, I told you how to compute if voltages are known, then automatically branch current from this simple mathematics can easily be computed, right. How it will be done? For further explanation, I have made it again, right. Say JJ is equal to 1, we have seen no, then JJ is equal to 1 means from this equation 27, JJ is equal to 1 means I1 capital I1 is equal to K is equal to 1 to N1, then I small I in bracket E1K, right. That means at N1 we have seen 7, from this table N1 is given 7, N1 is 7, right. You put N1 here, it is equal to 7, and this matrix when JJ is equal to 1, this matrix will be, this is for branch 1, JJ is equal to 1, that is matrix will be E1K, and this matrix already you have read in the computer, this matrix are already read in the computer, this as a data, this data is known, right. Actually, nowadays so many your languages are available for writing code, right, many software packages are available, but I am now an old man. Our time we used to write code in Fortran 77, later Fortran 95, right, and those things till date now my age is there, but till date I know those coding your thing how to make it, right. But anyway, question is that if you write the code, nowadays so many languages are available, right, C, C++, C sharp, right, so many things are there, but you have to write C first, then C++, then C sharp, many other languages are also available, the way you want, right, whatever it is, but you have to give anyway this data, first you have to read this data, right, and data reading also is very simple thing nowadays. Whatever I saw my student, they are writing code when they are running in front of me using laptop, right, things are very simple now, coding nowadays has become very simple, only you have to learn few different things like and C, C++, C sharp, but students always tell me that C sharp is very good, right. Anyway, the way you want, if you write any coding or anything on that, and if you send me the result by email rather than putting in forum in email, I will really appreciate that, right. So, now that means K is equal to varying 1 to 7, right. Now, that means capital I1 is equal to, like, first I am for your your clarification, I am writing I in bracket, I am writing E1 1 plus, because JJ is equal to 1 and K is varying 1 to 7. So, I E1 2 plus I E1 3 plus I E1 4 plus I E1 5 plus I E1 6 plus I E1 7. This way I am writing breaking. Then that E1 1, this data you have read in the computer, So, E1 1 is equal to 2, E1 2 is equal to 3, E1 4 is equal to 4, E1 5 is equal to, E1 4 is equal to 5, E1 5 is equal to 6, E1 6 is equal to 7 and E1 7 is equal to 8. That means, if you put it, capital I1 is equal to I2 plus I3 plus I4 plus I5 plus I6 plus I7 plus I8. It is coming no from this simple expression, right. So, for this one simply you can put it into the code, right. For JJ, I mean you put in a 2 for loop, that is all. For JJ is equal to 1 to ln and for K is equal to 1 to JJ, solve IJJ, then NN, that is all, automatically it will take, right, because already E matrix already read in the computer. So, automatically it will take, right. So, similarly for I2, for everything I have written for you such that you should understand this, right. So, for JJ is equal to 2, I2 is equal to K is equal to N2 I E 2K, right. So, that means N2 is equal to 6 we have seen, right, and K is equal to 1 I E 2K, because JJ is K, it is E 2K, and now K is varying from 1 to 6. So, capital I2 is equal to I E 2 1 plus I E 2 2 plus I E 2 3 plus I E 2 4 plus I E 2 5 plus I E 2 6. So, E 2 1 all these data are read, it is 3 4 5 6 7 8, all these data are read in the computer. Therefore, I2 is equal to I3 plus I4 plus I5 plus I6 plus I7 plus it is, when it is E matrix, no, it is I actually, it is I28, right, it is I, right. Therefore, this is equation say 29. Similarly, for Jj is equal to 3, 4 up to your total number of branches, Ln is total number of branches, right. Branch currents I3, I4 up to ILN, in this case it is 7, Ln is 7 in this case, our case it is a node number, total node is 8. So, branch number this Ln our case it is 7, right. Therefore, can easily be computed from equation 27. I mean, from this equation you can, whatever equation we have made, right, from this equation you can calculate for other branches also, right. So, branch current calculation is shown, that how to do this. Of course, if initial values of I3 are known, and I showed you how to compute initial values of your what you call that your I, right. Now, what I will do, two algorithms will explain, this is the first one. Now, look, whatever I have explained, that is the algorithm, then I will take lateral branches, but question is that examples, after explaining two different methods, then I will take couple of examples for solving here, then we will come to the voltage stability part. So, algorithm is first in step 1, read substation voltage, that is V1, line data, that is Rx values, and load data, that is PL QL, right. Assume a flat voltage start, that is Vi is equal to V1 is equal to 1 angle 0, say for I is equal to 2, 3, NB is the total number of nodes, right. This is substation voltage, line data means nodes, branch, everything will come here in the line data, right. Now, from the matrix you form the matrix E j j k for j j is equal to 1 to Ln and then k is equal to 1 to Nj. That means, this data you please read it into the computer, you form the matrix, this after making this table you please read this data, right. So, this one actually instead of reading I have made it form the matrix. So, form first the matrix and read it in the computer for j j is equal to 1 to Ln and k is equal to 1 to up to Njj. So, Njj I means read line data means branch number, sending end node, receiving end node, total number of nodes beyond branch jj, Njj, all these things you have to read, right, everything whatever have been given in the table, all this data. After that you read E matrix, I have written form the matrix, but read E matrix for this one, this all these things you have to give it as a data, right. Here in the program also you can convert it to per unit system, but here data we assume in per unit, but when we will take the numericals we will show you that how to convert into the per unit values, right. Now, you say set iteration count, say it is equal to 0, instead of 1 I am making say it is equal iteration 0, then dV max, that is voltage difference maximum is 0. Calculate load current IP by using equation 26 for P is equal to 2, 3 NB. So, let me go to equation 26, this is equation 26, right. For P is equal to 2, 3, here I am writing 8 because 8 nodes we have taken, in general you have NB number of nodes. So, find out the load current IP, PLP, because PLQL known, initial values of V's are known because here it is flat voltage start, right. So, naturally initial values of load currents you can compute in per unit. So, that is why calculate your first IP using equation 26. After that you calculate branch current by using equation 27. Then once it is done, then you calculate the branch current whatever we have, we have shown that your Ijj is equal to sigma, right, your what you call that I is equal to 1 to n, k is equal to 1 to Njj small I E jj k, right. So, equation 27, that branch current equation you have given, there you use two for loops for calculate this branch current, directly you are getting it, right. So, once it is done, branch current is done, then this voltage I have shown you how to calculate voltage magnitude, set M1 is equal, I have told you that only one for loop is required. So, set M1 is equal to ISJJ, put JJ is equal to 1, right, ISJJ and M2 is equal to IRJJ, right, and compute receiving end voltage Vm2 by using equation 8, this is given. Calculate the absolute change in voltage at node M2, receiving end voltage for your what you call your M2 is equal to IRJJ. So, dV max, that is dV M2 write absolute, Vm2 minus Vv M2, right. So, what we will do, this Vv M2 actually it is not given here initially. So, initially when you assume all these things initial values. So, here once you make, then here you can, I am writing here, I missed it actually. Here you put some VB your I, right. You take magnitude, because here we are not magnitude, we are taking absolute, no need. VBI is equal to VI you take, right, for I is equal to 2, 3 up to NB, that also you make it, because this is initial values. So, I am taking your VM2 minus VBM2. After that, this VBM2 will be replaced by VM2, right. So, once this is done, now you check if dVm2 greater than dVmax or not, because initially we have said some dVmax is 0. If it is your dVmax to greater than 1, go to step 8, you put dVmax is equal to dVm2. Otherwise, go to step 9, that is increment branch number jj is equal to jj plus 1, right. They are starting from jj is equal to 1, you increment jj is equal to jj plus 1, right. And initially every time we are trying to find out what is the dVmax value, although initial value of dVmax you can set it to 0, we have set it to 0, right. And then what you call, then increase jj is equal to jj plus 1, right. Then if jj, as long as jj less than equal to ln, the total number of branches, you come to step 6, because step 6 again you have to, for jj is equal to 3 it will be computed, come to step 6, right. So, it is go to step 6, otherwise go jump to step 11, right. In the step 11, because every time going to it is computing dVmax, right, same as Gauss-Seidel method, you took a max of voltage difference. So, here also same thing we are doing, right. So, that is if dVmax less than epsilon, go to step 14, here solution has converged, otherwise you go to step 12, step 12 iteration count IT is equal to IT plus 1, right, and again set your step 13, you set VBM2 is equal to VM2. Initially we have assumed this one is this one, but now you have to set VBM2 is equal for M2 is equal to 2, 3 up to NB number of nodes. Then your what you call then step 12 I2 is equal to IT plus 1, and if solution has converged is okay, set this one, and here also when you are setting VB is equal to your this thing VBM2, then after that immediately will not come, I have missed one, it is go to your step where from where you are starting your computing this thing, step 3, right. So, again you come to your step 3. So, this way, and otherwise it will because iteration count is starting from what you call from here, but ultimately you have to again come to step 3, because again initially you will start dVmax is equal to 0. I missed this one, but I have written here, right. So, step 4, if it is less than epsilon, epsilon will be some value say 10 to the power minus 4, this value set, and then solution will converge, right. So, this is actually your what you call algorithm. So, till now look, there is no, first thing is here, there is no derivative involved, as these things happen for your what you call for Newton-Raphson load flow method, right. No derivative is there, right, and it is straightforward, only that you are exploiting the radiality of the network, that we are doing it. And the second thing is that if you use for distribution load flow, you have to go for coupled Newton-Raphson method for solving such things, right. For distribution system, generally decoupled or fast decoupled load flow, it does not converge actually, it most of the cases it diverges, but if you use coupled Newton-Raphson method, then it converges, right. But you have to use, you need to know that you have to evaluate that full Jacobian matrix is required, coupled Newton-Raphson method. But here there is no Newton-Raphson method, nothing is there, it is simply basically backward forward type, right. And you can easily solve this network, just network you are exploiting the radial characteristic of the network, right. So, things are very simple, nothing is there actually, and classroom purpose when I will solve this you will find it is much easier, and hope you have understood up to this for main feeder case, right. Now, next, because we have to generalize it, So, that is why main feeder case you have find easy, everything this same algorithm is applicable for generalized case also. So, for generalized case also algorithm will not be given, this is the same algorithm we will do this, right, same algorithm, but let us see now that generalized case, right. Now, as it is a classroom type of thing, so I cannot take a very large distribution network, but here I have taken a 9 node distribution network, right. So, this is a substation, right, 2 lateral branches have been taken. Listen, this whatever way we have explained the thing, this numbering of the nodes are arbitrary. Whatever way you number the node, your E matrix automatically will be formed from your formation of the node automatically. So, this node, there is no systematic way of node numbering, you just you put any number the way you want, you put it, right, in between 1 to 9. Suppose this is 1 2 3 4, I make it, this is 1 9, this may be 2, this may be 5, and this may be your 4, the way I want, it does not matter. So, the way you want you can number, it is not a problem, just try to maintain the number should be in between 1 to 9. After that, wherever you put those number, it does not matter, because you have a 9 node, right. So, there is no only thing is that connectivity, according to connectivity you have to form this E matrix. E matrix is important, right. So, now this is substation, this is your 9 node problem. So, this 1 2 3 4 5 6, actually this is actually 1 to 6, actually say if it is called as a main feeder, we have from 2 another lateral branch, only 2 nodes are there in the lateral branches, because this is a classroom exercise. I cannot take very big network and cannot give one, then it will be very clumsy, and another lateral is there whose node is only one branch is there, right. And this is instead of 8 node, this is 9 node I have taken, such that your understanding will be easier. So, this is branch 1, all red mark in the bracket, these are branch number 1 2 3 4 5, this is your 5, then branch, this is branch 6, this is actually branch 6 I have written here, this is branch 7, and this is branch 8, right. Branch numbering also the way you mark, the way you give the node, that will give a branch number, automatically you will proceed, right. But to avoid the confusion, because when you generate the data in computer, we see in serial number 1 2 3 4 like this. So, better you put that your branch number accordingly, right. So, that means this is green color, these are all impedance Z1 Z2, that is R1 plus Jx1, R2 plus Jx2, these are all impedances. Everywhere load is given, look here I2 load is there, PL2 plus JQL2, but not shown here, then figure will be very clumsy, right. But for main feeder case we have shown, here it is I3 means PL3 plus JQL3 load is there. Similarly, I4 PL4 plus JQL4 load is there. So, everywhere for I9 PL9 plus JQL9 load is there. So, everywhere load is there, right, but not shown, but just in the main feeder case everything is shown, right. And branch, according to branch current also suffix I1, but when you write your mathematics form, then it will be in bracket, right. So, now with this you make this table first. So, this is branch number, you have total node 9. So, you have 8 branches 1 2 3 4 5 6 7 8. Then sending a node, this is in short I have made, because space problem here on this page. So, this is send means sending a node, M1 is equal to ISJJ, receiving a node M2 is equal to IRJJ, nodes beyond branch JJ, these are the nodes beyond each branch JJ, and NJJ, total number of nodes beyond branch JJ. Look how it is. You consider branch 1, this branch JJ is equal to 1, branch 1. Sending end is 1, receiving end is 2, sending end is 1, receiving end is 2. How many nodes are there beyond this branch? 2, 3, I am just counting 1, 2, 3, 4, 5, this is 6, this is 7, this is 8. Beyond this branch 8 nodes are there. So, it is I am putting 8, and what are those nodes? 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7, 8, 7, 8 and 9. These are the node 2, 3, 4, 5, 6, 7, 8 node. This is node beyond branch 1, right. Now, next is nodes beyond branch 2, this node. As soon as you are coming to branch 2, these are actually back. This you need not look back, right. You have to look the forward side, right. So, beyond branch 2, what are the nodes? Look 3, 4, 5, 6 and 9. That is why I have taken lateral branches to generalize. 3, 4, 5. Beyond this branch, these are the nodes. So, it is 3, 4, 5, 6, 9. So, 5 nodes are there, that is why n j j, that is n 2 is equal to 5, right. Next you come to branch 3. Branch 3, how many nodes are there? 1, 2, 3, that is 4, 5, 6 and 9. So, 4, 5, 6 and 9, these are the 4 nodes, and total, your total node is 4, because 1, 2, 3 and this is 4. So, this is 4, right. Similarly, if you come to branch 4, that means this branch, if you come to this branch, right, if you come to this branch, then the total number of nodes this branch is 2, because 5 and 6. So, come to branch 4, the total number here is 2, and which are those nodes? 5 and 6. So, this is 5 and 6, these are the nodes, right. Similarly, if you come to branch 6, right, when you come to branch 6 here, right, this is the branch, that only beyond this branch only one node is there, that is 6. So, n j j is equal to 1, this is only one node, and which are the node? Which is that node? Node 6. So, this is node 6. Now, you come to branch 6, that means this is the branch. Beyond this branch, how many nodes are there? 2. So, this is n 6 is equal to 2, it is 2, and what are those nodes? 7 and 8, this is 7 and 8. Now, come to branch 7, this is branch 7. Beyond this branch, which node is there? Node 8 is there. So, node 8, and how many? Only 1. So, this is 1. Similarly, you come to branch 8. Branch 8 means 4 to 9. So, 4 to 9, this one, right, and here it is your what you call your beyond this branch only one node is there. So, it is only one, and which are that node? Which is that node? It is 9. So, it is 9. Now, connectivity is, look, 1 to 2, 2 to 3, 4 to 5, 5 to 6, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, right. Then note, when you coming to branch 6, the sending end node is 2, receiving end node is 7. So, it is 2 to 7, right, because this lateral is emerging from node 2. So, it is from this branch 6 is actually 2 to 7, 6 is 2 to 7, then 7 to 8. Similarly, this branch 8, it is emerging from node 4. So, 4 to 9. So, here sending end is 4 and m to 9, and if you calculate using the same thing, automatically your voltage and your current same way if you calculate, it will be calculated, but only thing is that you have to compute the EJJK matrix. So, this is actually element EJJK matrix, right. So, this is actually main feeder with lateral branches for explanation. So, just if you see, for example, we have to, our objective is now everything has been explained before. So, nothing to explain, all connectivity, everything will match with the previous algorithm. Only you have to form this your EJJK matrix, and these are the elements for EJJK matrix. These are the element, right. For example, in this case also define matrix EJJK, right, for JJ is equal to 1 to Ln and K is equal to 1 to NJJ. In this case, Ln is equal to 8, because 9 nodes are there. So, number of branches is 8 and K is equal to 1 to NJJ. That means, for each one JJ is equal to 1, 2, you have to see. For example, when JJ is equal to 1, NJJ is equal to N1 or is equal to 8, right, and that means your E11, E12 matrix up to E1 to get. So, E112, E123, E134, E145, E156, E167, E188, E178 and E189. So, look, E112, E123, this data you have to read in the computer, this data you have to put it into the computer, right. So, the E112, E123, E134, E145, E156, E167, E178, E188. From the inspection you can form this matrix and feed it in the computer. Similarly, when JJ is equal to 2, NJJ is equal to N2 is equal to 5, right. Look at this, when JJ is equal to 2, NJJ is equal to N2 is 5, and that means your E21 is 3, E22 4, E23 5, E24 6, E25 9. Look at that, E21 3, E22 is equal to 4, E23 is equal to 5, E24 is equal to 6, E25 is equal to 9. This way, just these elements I have given to you such that you can easily form the matrix and put in the computer for reading. Thank you very much. We will be back again.